Hi, welcome back to my YouTube channel. Please do well to subscribe to Massa Tutorials. Please, for further information, please kindly contact 05410864890, or drop any problem you have or your grievances at the comment section so that I'll attend to you later. Alright, we are continuing with our JHS 3 topic, which is the right angled triangle, known as the Pythagoras Theorem. The right angled triangle known as what? The Pythagoras Theorem. So now we have an example here. We are still solving examples of what we did the last time. So we have an example in the diagram below. Calculate. When you see this, it means what? The length of what? Kill r. So calculate the length of what? Kill r. In my last video, or in my last 2 videos, I gave you other names for length, which is length, modulus, magnitude. Then we have what? Distance. So let's proceed. How do you find for the distance from this point scale? From this point scale to this point r. How do you find for the distance from this point scale to this point r? Now, we have the distance from point P to point N, which is what? 12, right? From point P to point what? N is what? 12, right? So now, let's see. Point P to point N is 90. The angle here is 90, sorry. The angle there is 90. So here is 90 degrees. So now, if you want to find for the distance or the length from point Q to point R, you first have to what? You must first find for the distance from point Q to point what? N. And also you find for what? The distance from point what? N to point R. Are you getting it? If you want to find for the distance from point Q to point R, you have to first find the distance from point what? Q to point what? N. Then you find the distance again, you find for the distance from point what? N to point R. When you are done with all these things, you find for what? The summation of the two distances. You find for what? The summation of these two distances, which will give you what? The length of what? Kill r. So you sum the distance from kill n, then and also n to what? R. So you sum them, then you get what? The length of what? Kill r. So let's see. Solution. How will we find for the distance of kill n? So let's see. Let's consider triangle PQN. Considering triangle PQN. Considering triangle PQN. So now let's see. So I have this triangle here, PQN, which is 90. I have my angle here to be 90, then here is 12, then 13. So how will I find for QN? By using what? The Pythagoras theorem. Because this figure here, or this plane figure here is what? Is a what? It's a right angled what? Triangle. So now here, you first have to what? Locate the what? The hypotenuse. You first have to what? Locate the hypotenuse. I told you that the hypotenuse is the longest side, or where the what? The angle is opposite to the what? To the side. So where this angle 90 is opposite to this side. So it means that this side from point Q to point P, or the distance from point Q to point P, is the what? Hypotenuse, because the 90 degrees, this 90 degrees is facing this side. So it means that the distance of QP is what? Is the hypotenuse. So now, I now know my what? Or we now know our what? Our hypotenuse. So we can start with what? By using what? The Pythagoras theorem. Pythagoras theorem also states that what? The square on this hypotenuse, the square on this hypotenuse is equal to the sum of the squares on the other two what? Sides. So the square on this hypotenuse is equal to what? The sum of the squares on the what? Other what? Two what? Sides. Alright, so it means that the length of QP all squared, because this is my hypotenuse, must be equal to what? The length of what? Pn all what? Squared. Then I'll add it to what? The length of Qn all what? Squared. So the length of QP all squared, that's 13 squared, equals Pn all squared, that's 12 squared, then plus, here I don't know any distance there, so still maintains Qn all squared. So 13 squared means what? 13 times 13. Then 12 squared means what? 12 times 12. Then plus what? The length of what? Qn all what? Squared. Please, you understand what we are doing here? So 13 times 13, which is what? 169. I believe I told you to learn your perfect square very, very well. Alright, then 12 times 12 is what? 144. Then plus the length of Qn all squared. Right. Okay, so we'll group like 10. So I have 169 minus 144 equals what? The length of Qn all what? Squared. So 169 minus 144 gives what? 25 equals what? The length of Qn all what? Squared. So now, what do we do? Now we are solving it together. So what do we do? We what? We take what? The square root of what? Both sides of the equation. Why? To remove this what? Square. So now, 25. So that means the square root of what? 25 equals what? The square root of what? The length of what? Qn all squared here. So this square cancels what? The square root. These are here. Alright, so now the length of Qn gives what? Square root of 25 is what? Is 5. Now there is no unit here, right? So you have to write what? 5, then you spell what? Units. Units. This is equal. So we are done with the first section. Now we know what? The length of what? Qn. Right. So we have to find for what? The length of what? Nr. The point from this point N to this point R was the length. So you can pause this video, then you try and see. Try. Alright, so let's go. So I can also say that considering triangle PNR. So I have my triangle as that. Triangle PNR. So PNR. So this place is also 12 because that's the same length we are using for this plane figure and also this plane figure. So now I have here to be what? 15, right? So now let's go. So still we have our right angle here, which is the 90 degrees. So we are still using what? Pythagoras theorem. Pythagoras theorem for this question. So Pythagoras theorem states that what? The square on the hypotenuse is equal to the sum of the squares. The sum of the squares on the what? On the two shorter what? Sides, or on the what? Two what? Sides is the same thing. So it means that the length of PR or what? Squared equals what? The length of PN all squared, then plus the length of NR all squared. Now the distance from N to R is the same distance from R to N. The distance from Kumasi to Accra is the same distance from what? Accra to Kumasi. It's the same distance. Alright, so the length of PR is 15, so all squared equals PN all squared, that's 12 all squared, then plus NR, we don't know, all squared. So 15 squared means what? 15 times 15, right, equals 12 squared is what? 12 times 12, then plus NR, all squared. My brothers and sisters, those who are preparing for the BC, please, at this point, you have to what? Show step by step method. Don't jump any step, please. It's very, very important in mathematics. Don't jump any step. Every step you take is very, very important. Alright, so 15 times 15 gives what? 2, 5, 2, 2 what? 5 equals 12 times 12 gives 144, then plus NR all what? Square. So we group like 10. We group like 10. So which is what? 225 minus 144 equals what? The length of NR all squared. So now let me clean. My board is too small. Let me clean this place. So far as you have the question, yeah, okay. So let me clean this place. So now let me continue here, right? 225 minus 144 gives us what? 81. 81. So equals what? The length of NR all squared. So now 81 equals, what do? We take what? The square root of what? Both sides of the equation. So this one, then that. So I get the length of NR equals what? 9 what? Units. 9 units. So now there's the distance from what? N to what? R. Point N to point what? R. Then there's the distance from what? Q to what? N. From point Q to point N. Now they said we should find for the distance from what? Point Q to what? R. I already said that if you want to find for the distance from point Q to point R, what do? You sum the distance from N to R, then to what? To the distance from what? Point Q to what? Point N. So it means that the length of QR gives us what? The length of QN, then plus what? The length of NR. So it means that the length of QR equals, the length of QN is what? 5, then plus 9, which is what? 11, which is 14 units, which is 14 units. 14 units. So we are done with our question. So that's the solution for the question. So that means the distance. So therefore, the distance from point Q to what? Point R is what? 14 units. So please go through, please. All right. Okay, so now let's move on to the next example. That's my last example, That's my last example. Then we move on to the next subtopic under Pythagoras theorem. So alright, so we have a question on the board, which is what? In the diagram, angle PQRS. So in the diagram, angle PQR, the diagram angle PQR equals 90. The diagram angle PQR equals angle PSR, which is equal to 90 degrees. Alright. So sorry for that. In the diagram angle PQR is 90. Then it's equal to what? Angle angle PRS. PRS. So we have PQR, which is 90, and PRS, which is also what? 90. So they are the same, right? So now the question says find what? The length of RS. So how do you find for the length of this RS here? So I can denote it by what? Letter X, or variable what? X. So now let's proceed here. So now, if you want to find for this X, when you consider this triangle only, you can see that they have given you only what? One distance or one side. You don't know two sides of what? This triangle. Please, are we here? When you take only this triangle and you say that you want to work with it, you have to what? You have to check whether they have given you what? Two sides before to get what? One what? Side. So now here lies the case that we have what? Only what? One side what? Given. So two sides are not what? Given. But if you consider this triangle PQR, we have what? Two sides. So we can use it to find for what? One what? Side. Please, do you understand that? Alright. So it means that we should what? Consider triangle PQR, so that we'll use the two lengths or the two sides to find for what? One what? Side. Again, we should consider what? Triangle PQR, so that we'll use what? The two lengths given to find for what? One length. Do you understand that? Because in mathematics we use what we know to find what we don't know. We use what we know to find what we don't know. So now here, solution. I'll consider what? Triangle PQR. So considering triangle PQR, PQR. I have my 90 degrees, so 4 and 3 centimeters. So now, when you consider this triangle PQR, we have to find for what? This length here. We have to find for what? This length here. So considering triangle PQR, we have to find for this length by using what? Pythagoras theorem. If you want to use Pythagoras theorem, then you have to find for what? You have to first note that where is my hypotenuse? I believe I told you that the hypotenuse is the longest side, or where the 90 degrees faces. Where the 90 degrees is opposite to what? To the side, then that means you can get your longest side or your hypotenuse. So where this 90 degrees faces is the what? Is the hypotenuse. So it means that the length of PR or what? PR all squared equals the length of PQ all squared plus the length of QR all squared. So QR all squared. So now, if you locate the hypotenuse, then that means everything will be simple for you. If you locate the hypotenuse, then that means you get everything simple. Because if you have the hypotenuse, we have everything. Which is what? The square on the hypotenuse, which must be equal to what? The sum of the squares, not the squares of the sum. Please, the sum of the squares on the what? On the two shorter sides here. So now, PR all squared, we don't know that, which is equal to what? PQ all squared, which is 3 squared, plus QR, which is 4 squared. So I have PR, the length of PR all squared equals 3 squared is 3 times 3, which is what? 9, plus 4 times 4, which is what? 16. So 9 plus 16 gives 25 equals the length of PR all squared. So now what do? We have to take what? The square root of both sides. Why? Because so that the square will go away. So now here. So I have the length of PR, which is what? 5 centimeters. So we know the length of PR, 5 centimeters. So now we can use this 13, then this 5 to find for what? This X here. We can use this 13 and this 5 to find for what? X, to find for RS, which is what? X. We denoted it by what? X, but the question says find for what? The length of what? RS. So when you are done with everything, then you see that therefore the length of what? RS is so and so. So now let's see. So now we can consider what? Triangle PSR. So we can consider triangle what? PSR, which is that. So 90 here, then we have our R, then S, then P. So 13, then we have 5 centimeters. Then we can get for this side. So now where this 90 degrees faces, that means this 13 or this PS is our hypotenuse. So it means that the square on this 13 squared equals what? 5 squared, then plus what? S squared, right? 13 squared is what? 169 equals 25 plus what? S squared. So we group like terms, then we get what? 169 minus 25 equals what? X squared. Now let's clean this place and let's proceed. So it means that 169 minus 25 gives us what? 144, which is equal to what? X squared. So I'll take the square root here, then the square root there. So X will give me what? 12 centimeters. 12 centimeters. So it means that X is 12 what? Centimeters. So the length of RS is what? 12 what? Centimeters. So when you are done, therefore the length of RS equals 12 centimeters, which is very, very simple. Very, very simple. Please, on our last video for this topic, I gave exercises, right? So if you are done, you can drop it at the comment section so that when I come, I just see it, then I mark it for you. Or if you want to chat me or if you want to call me directly, my number is 05410 86489. 05410 86489. Alright, so please do well to subscribe to my channel to get more GHS mathematics videos. So today, because I've given you more exercises on my last video, today we are okay. When we meet on our next video, we'll start with applications of Pythagoras theorem, or applications in using what Pythagoras theorem. So we are using the Pythagoras theorem to solve what problems on that, or to solve our daily life activities. So applications of the right angled triangle are known as the Pythagoras theorem. So we'll deal with the application. So when you hear application, it means we'll use that for the daily life activities. Application. How can we apply this Pythagoras theorem into our daily life activities? How can we apply this Pythagoras theorem we are learning here into our daily life activities? And true, we can apply it. So we'll meet on our next video. Please do well to subscribe to my channel, Massa Tutorials, for more GHS mathematics videos. Thank you and have a nice day. Bye bye.